All right, so we have talked about 2 unit conversions. Today we're going to talk about converting using a balanced chemical reaction. So we're going to talk about the unit conversion we're using today is called the mole ratio. So let's look at what we're talking about. So there's a balanced chemical equation here. This is telling us, it's kind of like a recipe. So this is telling me 1 molecule of nitrogen gas plus 1 molecule of oxygen gas. If I combine those, we get out 2 molecules of NO. Okay, we're pretty familiar with that. The other thing that we can think about is this is 1 mole of N2 plus 1 mole of O2 gives us 2 moles of NO. Okay, so we can either think about these coefficients in the front as molecules or as moles. So today we're going to think about them as moles. So if I have 1 mole of nitrogen, I should be able to get out 2 moles of NO. Or if I have 1 mole of N2, my recipe is telling me I need 1 mole of O2. Okay? Or if I have 4 moles of N2, how much O2 should I have? Yeah, 1 to 1. So 4 to 4. Good. Okay. So that's what we're going to think about today. The other thing that we can use this balanced chemical equation for is these mole ratios. So just like you did in your head, if I have 4 moles of N2, then I would need 4 moles of O2 to balance that, to react completely. Or if I start with 2 moles of N2, how many moles of NO should I get out if I start with 2 moles of N2? So I just multiply by 2, so it would be 8. So if I start with 2 moles here, then I should get double what I started with. I should get 4 moles out. So what we're going to use is these mole ratios. So these mole ratios, these numbers are just coming straight from the coefficient, the number in the front of the, in our balanced chemical equation. So if I have 1 mole of N2, I need 1 mole of O2, 1 to 1. This ratio is 1 mole of N2 for 2 moles of NO. Or 1 mole of O2 for 2 moles of NO. Yes. Yes, we take the whole class. All right, questions on that? Does that kind of make sense? So that is our unit conversion today. Our unit conversion that we're using is the mole ratio, and that's from the balanced chemical equation. Okay. So let's go ahead and draw another diagram. So this is our 3rd diagram for units. So let me erase this and we'll write this. So this would be helpful to have somewhere, probably in your notes. You can also write this if you want. You can write this on your periodic table. So what we're trying to do today is we're trying to go from moles of A to moles of B. And we can also go the other way if we're going from moles of A to moles of, or moles of B to moles of A. So what we're going to use is we're going to use the mole ratio. And remember, this is from the balanced chemical equation. I'm going to write chemical equation. So when I'm looking for the mole ratio to go from moles of A to moles of B, I'm looking at the chemical equation. And remember, the chemical equation needs to be balanced. So if I go from moles of A to moles of B, my ratio is going to look like this. Moles of B is going to go on the top. So whatever I'm trying to find, that goes on the top. Whatever I started with, I need that to drop out. I need that to cancel out. So if this is what I start with, that's going to end up on the bottom. The number from the chemical equation will go on the bottom. Okay, and we can also go the other way. If we start with moles of B, then that needs to go on the bottom because it needs to drop out. So moles of B goes on the bottom, moles of A goes on the top. Okay, and this is our mole ratio. So when we're talking about the mole ratio, we're just looking at the numbers in front of the coefficients in front of our chemicals in our balanced chemical equation. Okay, questions so far? Reading okay? Try not to stand in front of there. Okay, so that's there. So let's go ahead and just do an example together. So I have a few examples, and we'll see if we need to do a lot of examples, or we can jump to our homework. So this says, using the balanced chemical equation, that means it's already balanced. How many moles of CO are produced from 3.5 moles of C2H6? So the first thing that you're going to do is you're going to write down what you have, what you start with. This is called our given value. So we start with 3.5 moles. And I'm going to write the chemical also. 3.5 moles of C2H6. Okay. And then I'm looking for how many moles of CO are produced. So that's the unit at the end is going to be moles of CO. So this is like I'm going from moles of C2H6 to moles of CO. So whatever I'm trying to end up with goes on the top. Whatever I start with needs to cancel out on the bottom. So this is my unit conversion. Okay, so moles of CO needs to go on the top. So moles of CO. And the number that goes with moles of CO is just from my chemical equation. So I have this 4. This is saying 4 moles of CO are produced in our balanced chemical equation. Are we okay? So this 4 just came straight from the balanced equation. And then this needs to cancel out, so it's going to go on the bottom. Moles of A needs to go on the bottom. Moles of C2H6. And then what number is in front of C2H6 in the balanced chemical equation? 2. Okay. So the mole ratio, all of the numbers here come straight from the balanced chemical equation. So this is our number there. You following? Is that okay? Okay. So then moles of C2H6 cancels. Our answer will be in moles of CO. And then we just multiply across. So 3.5 times 4 divided by 2. We could also simplify this. If we wanted to, we could say, oh, this is actually just 2 on the top. So what's 3.5 times 2? 7. Good. So let's go back. So if we start with 3.5 moles of C2H6, this is telling us, our balanced chemical equation is telling us we should expect 7 moles of CO out of our chemical equation. Does that make sense? Okay. Okay, very good. Okay, let's try another one. Are you ready to try one, or should we keep going together? You ready to try one? Okay. Okay, you guys try this one. So I'm just going to tell you C2H2 is acetylene. This is C2H2. It just has the structure there. So go ahead and see if you can figure out this one. Where did you find this? Did you make this shift?
From that.
Yep. Good. Yes. All right. Are we ready, or do we need a minute? Yeah, give you something. You're not speaking to me. Are you ready? Okay. Okay, so we are going to start with this number. We have 6 moles of C2H2 or acetylene. And what are we trying to find? What's our answer? Or what will our answer be? What units? Moles of CO2. Are we okay? Did I miss something? Oh, I skipped it. Okay, thank you. Thanks. So, thank you. So let's erase this. Okay, let's start over. Okay, so now we have 5 moles of C2H2. Okay, this one. What will our answer be? Okay, moles of O2. All right, so then what needs to go on the top of our unit conversion? Good, 5 moles of O2. And what should go on the bottom of our unit conversion? 2, let's put moles. 2 moles of C2H2. Good. And let me erase some of these. Okay, so are we seeing how we get this number? So this one needs to cancel out, moles of C2H2. So that's why I put that on the bottom. This 2 is from the chemical equation in the front. So everything in our mole ratio comes straight from our chemical equation. And then the 5 also is just right here. We have for every 2 moles of acetylene, we need 5 moles of O2. So that's our mole ratio. Moles of O2 needs to go on the top because that's what we're trying to find at the end. Okay, what did you get? 12.5 moles of O2. So if we start with 5 moles of C2H2, according to our balanced chemical equation, we need 12.5 moles of O2 for the all 3 atoms. 5 times 5 is 25. Divided by 2 is 12.5. Okay. Okay, yeah, good to check. Good to check. Someone found an error in the key last hour, so good to check. Hey, are we following that okay? All right, so we could do more examples. I think I have 3 more examples, or we could do our homework. What are you guys thinking? You ready? Okay. Okay, so on the assignment, there are 5 questions. Each one of those you have to balance, and then you can do the question. Okay, I'm gonna hand this out. Number 1 is a trickier balancing question. So see if you can balance it, and then I'll come back in like 5 minutes, and we'll write the coefficients in together if you haven't figured that one out. Okay, and then we just need to turn in 1 page. Oh, so this is 5 questions. I think almost everyone, if they were on task, they finished during the first class. If you have extra time, check for missing assignments. We have not had a lot of time to do the other 2 assignments. So we should have extra time in our class today. So use that time to catch up. So if you need more time for the other 2 worksheets, once you're done with this one, do that. Does that make sense? That's our in-class time. Okay.